Hello, robotics and engineering students. We're going to do another video about Fusion 360 for you to complete by this coming Sunday. This video is going to deal with gearing, and many of you have asked questions about how to create gears, and there are many ways to do it. This is a simple way to do it. One way that we've done it in the past is actually just bringing in gears from McMaster-Carr, but this will be a way for you to make your own gears, but still do it very quickly and efficiently. So we'll show you how to make those gears quickly and then how to actually make those gears turn in the manner that you want them to. So let's get started. So the first thing that we're going to do here is come over to the Tools menu up top, click on that, and we're going to use something we probably haven't used much in class or talked about, and that's the scripts and add-ins. Click on that, come over to add-ins up here at the top, and then scroll on down to spur gear. Now, we can use there are two different kinds of spur gears. The difference here is these are basically code that kind of run a script. One is made with C++, one is made with Python. It doesn't really matter which one you're going to use. I have already used this one here, and so normally what you'll see, if I click on the one above, just a run button, you'll go ahead and click on this run button, and then you'll get a little pop-up that you can clear. And then if I came back over to Solid Tools, Create, and came down to the bottom of the menu, you'd see spur gear. And so this will set up a pop-up menu for us to create that spur gear. So spur gear here is open, this little dialog box. We'll go through some of these options. The first is English versus metric. Today we're just going to use the metric, or the English version, but you can certainly do this using metric if you want to play around. You do not have to follow exactly what I'm doing here. You can make your own size gears and whatnot. I'm just going to show you one specific way to do this. We're going to keep our pressure angle of 20 degrees. You'll see there are some pre-chosen options here. 20 is a common degree or angle to use, and so I think we're just going to stick with that today. The pitch here and the number of teeth ultimately will affect down here your pitch diameter. You'll see this is just a number that we cannot change. We can only change it by updating these two numbers here. I'm going to change this to, let's just say 32. And you can see down here, that means this pitch diameter, which is the complete outer diameter. You can see the arrow pointing to what the pitch diameter is here. So it's not the kind of outer edge. It's right here. But that's 16 inches. That's pretty big. I don't really want to have a 16-inch gear. So let's play around with this number to bring this one down. Okay, we'll use 12. And you can see I'm getting a little message down here saying the root fillet radius is too large. We'll come to that in a second. We're going to change this backlash here. That's just going to give us a little extra tolerance. 3D printed objects need a little bit of extra tolerance, so it won't. So the fit will be a little bit maybe looser, but it'll be better for us with the 3D printing that we're going to do here. I am just going to make this 6. So 0.006 for the backlash. The root fillet radius here you can see must be less than 0.049, 0.492. So if we just go ahead and make this 0.049, that should go away, and that'll take care of that. You want to make this as big as you can. You can see it's down in here. It is kind of this radius that comes to the bottom of this indentation for the gear. We want it to be as big as we can make it, but not too big, because then the gear won't fit, kind of sit in here as it's going through. Gear thickness, that's just the sort of thickness of the part. We can half an inch is a little thick, so I'm just going to make it 0.25. And then the hole diameter, that is this hole diameter. If you type in 0 here, you'll actually have no hole diameter, which is kind of nice because then you can actually make your own later. And by doing that, you can update that hole diameter. So it gives you a little bit of flexibility. Once we hit OK here, it's actually kind of hard to change all these options. And so allowing that to be 0 gives you a bit of flexibility with the part. However, today We're not going to do that. We're just going to keep it at 1/2 inch. All right. Actually, let's do 0.25 inches. So here's the settings you should have before you click OK. And look at that. We got ourselves a gear. Not too shabby, huh? So we are going to make a second gear in a 2-to-1 ratio. In order to do that, our next gear will have 1/2 as many teeth as this one. You can now use that S command to type in spur gear. Which is really nice. And here we are going to change this number to 16. So 16 teeth, that's 2-to-1. And I think everything else should be about okay. So let's go ahead and hit OK. There's our new gear. Okay, so now we need to actually move this gear. And so the way to move it is we need to move it so that the pitch diameters align. So we're going to move it 1/2 of the pitch diameter of the inner gear plus 1/2 the pitch diameter of the outer gear. So that's the way we'll do this is we'll use our move tool, go to components, and let's get the small guy. And up here in the distance, we can type in a quick formula. And so the diameter of the small gear, if you remember, was 1.333, repeating basically. So I'm going to type in 1.334 inches divided by 2. And don't forget those parentheses. And the larger gear was 2.666, repeating. So we'll type in 2.667 inches divided by 2. And then dividing by 2 gives you the radius, and then that moves that just the radius. And there you can see it's moved. And what we want is these green dotted lines. That's the pitch diameter, and we want them to line up right here, being basically tangent to each other. So that looks pretty good. The next thing we want to do is just give this we want to rotate it so that the gears look aligned. Let's see here, axis. So we'll select this interior circle here as the axis. And I'm just going to kind of slowly bring it in here. We can maybe zoom in to. So it's moving. As I turn that, the incremental values are not quite what I'm looking for. So I'm going to start to type in some things here. Let's see, 11. 11's not bad. If we go to 12, and I'm going to turn this fully to the top here. I'm going to go back to 11. And maybe just give it a little bit of help there. I like that. That looks pretty even. 11.3 is what we're going to use there. And I'm going to hit OK. Now, let's go ahead. We're just going to create a small base for these things to sit on. And so let's do, we'll grab this actually. Uh-oh. It's thinking for me. It's thinking. I'm going to get rid of these real quick. There we go. And now let's bring them back. And let's use the project tool. And let's project those. And then let's use offset. And let's do, I don't know what the offset should be. Maybe we'll just select 0.5. And let's do that again here. I'm just clicking O for offset and grabbing that. And we'll type in 0.5. Okay, that looks good. All right, so now I got that. I'm just going to look around here. So now what I'm going to do, I'm just going to hide these guys again. Let's go ahead and extrude these. And I'm going to use something I don't use very often. I'm not going to start it at the profile plane here, we're going to just do an offset distance from it, and let's give it point, you know, 0.5 inches here. Negative 0.5 actually. And that looks good. And let's have it be 0.5 inches. How about that? Actually, make it 0.25 inches. Okay. There we go. So now I got that in there. And if we put our gears back, you can see they're kind of raised up a little bit, which is kind of nice. And they should be raised up about 0.5 inches from there. The next thing, I'm going to create just something for these to, a little pin for these to rotate around. So let's go ahead and we'll create a sketch on the top of this base, just like that. And I'm going to do the project tool again. And we'll grab that and that. Click OK. And then I'm just going to hide them for now. And then I am going to offset because this would be like an exact match. We're going to 3D print this. I don't want it to be that. So let's have it kind of come in maybe 0.015, just like that. And let's do the same here. Oh, I can't. We'll just do that again. 0.015. There we go. Now, finish the sketch, extrude. You see I'm just grabbing that inner guy. I'll just grab this inner guy too. And we'll go up. Let's just go up an inch. I'm going to do one more thing here. Just going to edit this sketch. And let's do another offset. We're going to go the opposite direction from this, just to give it something to sit on. And let's make it, I don't know, 0.5. That's fine. And we'll do the same over here. Offset. I don't know. Make it 0.25. Alright, so now we got those. And let's make sure we can see that. And we'll extrude those up. Let's extrude these guys up. 0.25, 0.25. Cool. So let's take a look at our gears again. They should be. Okay, so let's go ahead and get the revolution of the gear started. And we're going to add an as-built revolute joint. I'm just going to turn it a little bit here. And we'll go to assemble, and we're going to choose the as-built joint. And we'll select this component and this component. We don't want them to be rigid. Revolute. And the position. Yeah, I'll just go ahead and select that top there. And there we go. So let's do that again. As-built joint. And we're going to choose this gear now and our bottom. And the position, we'll select. So now we have both of them able to turn, but they don't turn together. So what we can do is create what's called a motion link between these two gears. So if we go back to assemble, you'll see motion link right here. We'll click on that. We'll go ahead and click on these two joints here, and let's see what happens if we reverse it. Now they're going the right way, but what you can see is this one's turning too fast. So we need to slow it down. So we do need to change the speed with which the large gear is turning. In order to do that, we're going to actually multiply it. So we're adding a formula here, and we're going to multiply the gear. So 32, or actually let's do 16 divided by 32. And let's see now. Now you can see they're turning with the correct motion. So the 16 refers to the small tooth gear, the 32 represents the large tooth gear. So there you go. You should be able now to create your own set of gears that move together. Let's just double check here. If I do activate this one, you'll see they both turn together at the correct speeds. So you should be able to create your own gears now using Fusion 360, using that add-in that we found in the Tools menu. And if you have any questions, please find me on Discord or send me an email. Hope you enjoyed the video, and I will talk to you guys later.